What is the graph of the equation y equals 5/7 x? Well, first of all, we need to know that this equation creates a line graph. And I know this because it's a linear equation, and I know how to identify those. I can tell by looking at the variables y and x and making sure that they only have a power of 1. So once again, that means there are two different variables, x and y. There should only be two. And they each only have the power of 1. So now that I know it's a line, I also know that I only need 2 points, 2 pairs of x comma y coordinates that will give me enough information to figure out what the graph looks like. Let's talk about why this is true by looking at some examples. Let's say I have the origin point and I want to create a line. Well, I can't create a line unless I move away from this point with a second point, and that creates the ability to connect those 2 points and create a line. I can put that second point anywhere I want. So at this step, I haven't decided where to put my second point, even though this one is fixed at the origin. My second point needs a home. So the origin is decided. It's like I put a tack through, say, a ruler or a piece of string, and it's just stuck there. And now I can pull this out and go anywhere I want, but I have to make a decision in order for this line to be decided, because this line could be so many different, so many different lines I could make just by where I put the second point. So your line, any line, is defined simply by knowing where to put one point and then from there where to put a second point. So generally we like to know where to put the y-intercept somewhere along the y-axis, and from there we use a slope to move up a certain number of units and over a certain number of units until we get the steepness we want to create the line we're shooting for. And it doesn't always have to be that your first point is on the y-axis, but that's generally how we work it. You see y equals mx plus b, where the b tells you where to go on the y-axis, and then the slope tells you where to go from there to get to your second point. But in any case, you just need 2 points. It could be an x-intercept and a y-intercept, right? Just by knowing where to go on the y-axis and where to go on the x-axis will tell you how your line looks, will define the line. And it doesn't have to be on the axes at all. You could have any point anywhere and any second point anywhere, and that will define how the line looks. So long story short, we need 2 ordered pairs so that we can connect them with a straight line. Now, because there's a fraction involved, we want to be strategic about what we plug in for x to get the resulting y. Now, 0 is a good choice. In general, 0 is always a good choice because it evaluates easily, right? So will equal 0, as anything times 0 equals 0. So my ordered pair when x is equal to 0 is 0, 0. That was easy enough. The second x value I'm going to choose is the one that's going to cancel out this denominator and get rid of this pesky fraction. So I'm choosing 7 for x. So then I can calculate y again. So y is 5 over 7 times x, and this times x is 7. And we'll make it look like a fraction by putting it over 1. And so right now you can see that the 7 divided into 7 would equal 1 and cancel out. Or you can just multiply straight across to get 35 on the top, and 7 times 1 is 7 on the bottom. Simplifies to 5. And that means that my ordered pair here, 7 for x and 5 for y. So now I have my two ordered pairs, and that's all I need. I just need to plot these 2 points and connect them with a line. Origin here. Okay, there's our first point. Our second point was 7 for x. Let's zoom in a little bit. 7 for x and 5 for y. So let's go up to 5 for y. So I'm going to have my second point right there. And if I just draw a straight line, you can see that it does go through my 2 points. Now, I'm going to take that away though, and let's type in, I'm just going to type it in. You can't see it because it's out of your view, but I'm just going to type in the line y equals 5 over 7x. I'm going to type that equation into my graphing calculator here and see if it hits these 2 points. Oh, beautiful, beautiful fit. All right, so for you, you won't be using a graphing calculator. You need to know how to do it on paper. So make sure you know how to do it by hand. And hopefully this is eye-opening. From now on, you'll fully understand why you only need 2 points to graph a line, and also how to tell if the equation you're looking at is going to form a line.